Hello. In this session, we will discuss about programming abstractions. The principle of abstraction used in programming. We use abstraction everywhere in programming. Where we use this abstraction, in what way we are going to use the abstraction. So abstraction is nothing but taking the essential characteristics for the time being and neglecting the other things. Taking the essential characteristics for the time being and neglecting the other things. Means only for the time being we are going to consider some characteristics as essential. The others at that point of time we don't bother. Again, at a different level of abstraction, some other characteristics will be considered. So we use abstraction in our daily life. So in fact, we use abstraction whenever the problem is complex. Abstraction is necessary to cope with the complexity. That means to handle complexity, you require abstraction. Suppose you are using a programming language like C. So when you are using the programming language like C, you just bother about the syntax and semantics of it. Just bother about what is the syntax and semantics of the programming language called C. So in what way you have to write the statements. Never bother about how programs get loaded into the memory, how they are executed, etc., etc. That means you are using the principle of abstraction. In general, when you wear a suit, you never bother when you wear a suit, you never bothered about how the thread material is grown, how the suit is stitched, how it gets its color, etc. Want to go to a party, you are going to pick a suit and wear it. So you don't bother about other things like what is the material, how that material is grown, and what is the color, how it got that color, etc., etc. So map viewing is one of the best examples for abstraction. Why? So we take a world map, try to identify where the country is. Try to identify exactly where the country is. So, but we're not going to that country actually. You are doing it on a map, which is simplification of reality. Which is actually simplification of reality. The entire earth may be represented in a 1 by 1 feet chart. So again, there you are using the principle of abstraction. So we use abstraction in our daily life. So this abstraction has become noted. It exists from the olden days, but it became famous, particularly in programming, with the introduction of object-oriented programming. So what this object-oriented programming does is, it brings together data and operations. So it brings together data and operations that operate on the data together. So it brings together data and operations that operate on that data together. So that is collectively called as, in object-oriented programming, that is collectively called as a class. So class is an abstraction. Suppose you are executing a print statement which displays some content on the screen. Now how it works? So for using it, you never bothered about how the string is displayed on the screen. You don't bother about it. So you think only in terms of what is the function name, that is here the function name is print, and how to pass this parameter, the string. So you will be placing it in the double quotes and parentheses will be used. So that only you are going to bother. That only you are going to bother. So you'll be using it. But is it so simple? Is it so simple? No. So to print the string on the screen, number of things will happen. Number of things will happen. Try to know how complex it is. When we execute print through an user program, it results in invocation of the operating system functionality. Because this devices, the screen, the display, it is not under the control of the user. It will be controlled by the operating system. So when you use the print statement, operating system functionality is invoked. Operating system functionality is invoked. So maybe a system call is invoked. A device driver will be invoked. Device driver. That means a software which understands the device. A software which understands the device. So here the software is device driver. Device driver. So that device driver knows the intricacies of the screen, how the screen works. That is known to the device driver. That takes care of the intricacies of the screen. See, if you consider the screen is made out of pixels. So when you are printing a string means, so you have to eliminate different pixels at different points of time. Not point of time, you have to eliminate different pixels at different points on the screen. Different points on the screen. Maybe you have to refresh it so that string appears to you, because if you just display it, it may go away. Maybe if required, it has to be refreshed. So, but we don't bother about how the screen works, how the pixels are illuminated, etc. So we are just using the principle of abstraction. Operating system and computer network. These are the best examples for understanding the principle of abstraction. So the operating system and computer network, both are very, very complex software. And both are designed using the principles of abstraction. So here if you consider, we don't go into the details of these layers or all these operating system related things. This is operating system actually, this is computer network. Operating system, this is OS, this is operating system, and this is computer networks. We are not getting into the details of those things, but point to be noted here is, so all these, you can say hardware, device driver, system calls, system programs, these are different levels of abstractions. Different levels of abstractions. So we consider the bottom one, hardware. Hardware knows how to take care of, the hardware knows how to generate the signals, etc. Device drivers knows the intricacies of the devices, and then above it is system calls, above it is system programs, and above it is application programs. As a user, you will be using the application programs, and you will invoke an application like print to display it on the screen. But finally, it has to be achieved in the hardware. So these are different levels of abstractions. These are different levels of abstractions. So these are different levels of abstraction. We can say each level is the layer. The purpose of each layer to provide services to the layer above it. The purpose of each layer is to provide services to the layer above it. Okay. So operating system and computer network. Operating system and computer networks. So we will study more about the operating system and computer network in our future courses. Interface and implementation are differentiated. Again, this is also important. Differentiating interface and implementation is necessary. What is interface? What is implementation? So interface is what services are available, and implementation is how the services are provided. Interface is what services are available, and implementation is how the services are provided. In programming terms, we discussed about this print. Then if we consider print, so print is used to print the content on the screen. Maybe there will be scanf or read, something like some statement which is used to read from the keyboard. So if you know about the interface, then that means you know about the functions that are available. You just invoke them. But how the code is written, it is not your botheration. Suppose I will take an analogy. So you go to a movie. So there will be a ticket counter with a hole in which you can put your hand, maybe with money, and you get back the ticket. So what is interface there? Interface is you have to put appropriate money in your hand and put the hand inside that hole. That is the interface. Now what is implementation? Now how you got the ticket? How we got the ticket? So the person within that ticket counter, ticket counter may write it on a slip of paper, sign it, and give it to you. May give you a printout using a computer and printer. May give you a already printed ticket, or there may not be a person inside. Automatically, something like a robot will give or will place the ticket in your hand. That is all implementation. So you have to differentiate between interface and implementation. Primitive data types or fundamental data types. So every programming language will have what are called as basic data types, fundamental data types, or primitive data types. All are same. So like integers, real, etc. They will be the data types. A data type is nothing but the domain of values and the operations that can be performed on those values. A data type is the domain of values and the operation that can be performed on those values. Suppose if you take integer data type, the domain of values, maybe some negative value to some positive value. What are the possible values? And what are the operations you can perform? Usually, you can perform addition, subtraction, multiplication, etc. But usually, you don't concatenate 123, 567, 567. Cannot concatenate them. So as a programmer, you don't bother how the integers are represented, how many bits are used, what is the least significant bit, what is the most significant bit, etc., etc. And how the operations are implemented. But just know what are the data types, how to use them. Similarly, the user-defined data types. These also come under abstraction. User-defined data types means user himself defines some data types. Most appropriate term is derived data types. So using the existing data types or by combining these existing data types, he gets a new data type. Say a student. What is student? Student consists of say roll number, name, etc. Now here we are combining the primitive data types. So primitive data types means roll number is an integer, name is a string, address is a string, maybe again marks are numbers, etc. But we are combining. So user defined data type, derived data type are also an abstraction. And there is one term called that is frequently used called as abstract data types. So we abstract away how the operations are provided. We abstract away how the operations are provided. Suppose one example, stack is there. See, all these are complex things. We are just discussing a glimpse. I am trying to give you an idea that principle of abstraction is very important. Very, very important. Take a stack. Stack is defined as a data type. Now, what is stack? What is stack? So stack has some values. Stack has some values, and then it has two operations called as push and pop. So these are the two operations that are defined. Stack is defined like this. So you have data, and then the only operations are push and pop. What is push? Push to the top of the stack. That means at the top of the stack you will be placing the new item. Pop means removing the top element, removing the top element. Now this a stack, queue, etc. are considered as abstract data types. So here we are defining the values it takes and the operations that can be performed. Now these push and pop can be implemented in different ways. You will study about this in data structures. But stack is an abstract data type. Function is also an abstraction. In programming, functions will be there. Functions are also an abstraction. So, in fact, we discussed this print example. That is nothing but an example of function. So, function again differentiates between interface and implementation. So, function means function declaration means name of the function and then some parameters, what you pass it. Suppose in case of print, it is string. For passing some string to be printed. So like that, function will have name and parameters. So that is interface. You should exactly know the name of the function and the parameters to be passed. Implementation means the actual code. Implementation is actual code. Okay, while invoking a function, you don't bother about the actual code that is written. Only bother about what I have to pass, what I am going to get back. That is important. So this differentiation between interface and implementation is required, and this plays a major role in programming. File is also an abstraction defined by its creator. So that means what is present in the file is defined by the user. So the file can contain some data. File can contain your program, that is called as source code. File may contain an image. The file may contain video. Okay. So whenever you try to open it by double clicking or right click and select open, so appropriate application is invoked. Depending on the type of the file, appropriate application is invoked. So for example, an image consists of what is called as header part and the body part within that file. So header part provides the information. The application is going to check the header part. Is going to decide what is the type of the file, how the contents are stored based on the information there, and then it is going to display the image for you. So it consists of header and body. APIs similar to functions. Print we discussed, functions we discussed. Similarly, extension of it application programming interfaces. So APIs are nothing but a collection of library functions. APIs are nothing but a collection of library functions. Nowadays, programming languages are famous not because of their simplicity and efficiency, but because of the what is called as large number of APIs and large number of large user community. So large number of APIs. So for everything, you have some library function. For example, Python. Python is famous because you take any application area. You take robotics, data science, AI, mathematical related area, image processing, neural networks, whatever it be, there will be APIs. C is not that rich. C is not that rich. So that's why the Python is very famous. Last, database management systems which you are going to study are an abstraction created over the underlying file system. And World Wide Web is also an abstraction. Distributed system is also an abstraction. So if we take internet, internet is nothing but a collection of networks. Wherever the information is available, you are able to access. But it is the World Wide Web which brought the internet to the common man. Because if you have just internet, then if you want to access any resource, you should know exactly where the file or resource is available, explicitly get connected to it, and then download it if necessary. But World Wide Web is an abstraction that is created over it. World Wide Web is an abstraction that is created over it, and it takes care of everything. That means you will not bother about how to connect to the appropriate system. So it is the World Wide Web that takes care of it. So it is the World Wide Web that brought the internet to the common man. Otherwise, it would have been difficult. So thank you. Thank you. You are important to me. So enjoy. So this is regarding the fundamentals theory part that is required for you. But particularly this module 4, it may be little difficult to understand. I can provide you only a vague idea, because things will be clear as you move forward in computer science. It's something like a tunnel. In tunnel, initially you don't understand anything, but as you move forward, you'll get to understand. So you are important to me. So best of luck. Thank you.